In section 6.2, we're talking about trigonometric applications, and we're going to solve triangles using trigonometric ratios, and we're also going to solve application problems using these triangles. So in right triangles, or in any triangle, we can apply the triangle sum theorem, which says that the sum of the measures of the angles of a triangle is 180 degrees. And then also in right triangles, we have the Pythagorean theorem, and that tells us that a right triangle with legs A and B and a hypotenuse C, we can apply a squared plus b squared is equal to c squared. And then also you need to know that you're going to be able to use inverse trigonometric functions to like sine, inverse sine, inverse cosine, and tangent. We can also refer to those as arc sine to find angle measures in right triangles. And we're going to see how to do that here in a few minutes. So let's look at these two problems. In both examples, we have right triangles. So I'm going to add some markings. And we want to solve the right triangle, which means we want to find any missing values here. Okay. So first of all, let's start out by finding. In the first one, we're going to find. Let's see. I think I skipped a slide here. Here we go. All right, so in the first one we're going to find x. We're just going to find the value of x, okay? So we've got a right triangle, and make sure we have a right triangle over here. So if I'm finding the value of x, and I have this 50 degree, and I have this. So I have an angle, and from that angle I have the hypotenuse, and I want to find the adjacent side. So if I have the hypotenuse and adjacent, it's going to be more helpful if I write that as adjacent over hypotenuse. So I have adjacent and a hypotenuse. So that tells me that I want to use cosine. So I can now write that the cosine of my 50 degree angle is equal to my adjacent over my hypotenuse of 10. And again, I decided I wanted to use cosine because I have the adjacent and the hypotenuse is, or I have the hypotenuse and I'm looking for the adjacent. So that tells me cosine. So I'm looking for the value of x. You want to make sure your calculator is in degree mode. So I multiply both sides by 10. These cancel, and so x is going to be approximately 6.43. which the exact value is 10 times the cosine of 50. Okay. Now in the second one, I'm finding theta. All right, so if we write down our little thing to help us out, it looks like I have 5, and 5 in relation to theta is going to be my opposite. So I have the opposite, and I have, so there's an opposite, and I have my adjacent, which is my 12, so adjacent. So that tells me I'm going to use tangent. So I would say the tangent of theta is equal to opposite, which is 5 over 12. Okay, now this time I'm doing something a little different. I am trying to find this angle measure, and this is the first time we've done this. So if I want to find the angle measure, I can't just get rid of tangent. I've got to do my inverse tangent. So what I would do to find this is I'm going to do inverse, take the inverse tangent of both sides. Here. And so what this leaves me with on the left side is just theta is equal to the inverse tangent of 5/12. Okay, so now is when we're going to use that key on our calculator. So let's take a look at what we're going to use here. So I've got calculator, check my mode, and I am in degree mode. So that's good. So I want to use second tangent, pulls up the inverse tangent of 5/12. And I get approximately 22.62. And that's degrees. Okay. All right, now let's look at the next one. On number 3, we're going to find the two missing angle measures here. Okay, so I'm finding the two missing angle measures here, and it looks to me, hopefully you'll notice that you have these two are the same. Okay, so to find the first angle measure, I can say okay, and that's opposite over adjacent. So all right, and then so if I use the inverse tangent on my calculator, so I could probably show you one more step here. So we can say, just like on the last problem, and then we're going to get. Now hopefully when I said earlier that you noticed that you have two side lengths that are the same, that means that the two angle measures, the two angles opposite them are also going to be the same measure. So what we have is a 45, 45, 90 triangle. So we also know this. Or you could work it out differently if you wanted to by using the same. It's just the opposite is going to become adjacent, and adjacent is going to become opposite in this case. All right, and let's look at the fourth one. And this time we're finding this time we're going to find the value of A. Okay, we could find this value pretty easily just by using subtraction, because the sum of the interior angles of a triangle is 180 degrees. So that's going to be the 90-degree angle plus the 20-degree angle is going to give you 110. So that makes this a 70-degree angle here. Okay, so now let's go through and find the value of A. All right, so if we don't really know what we're going to use, so let's write this down. I want to find A, and let's say we're working with our 20-degree angle, okay? And from our 20-degree angle, our A is going to be our opposite. So we have an opposite. Let's underline my opposites. And then we have a 101, which is our hypotenuse, so here. So that tells us that we're going to use the sine. So since I'm using the sine, I can say that the sine, my 20-degree angle, is equal to the ratio A over my hypotenuse of 101. So A is going to be equal to 101 sine 20. Okay, and I can use my calculator to evaluate that, and I get A is approximately 34.54. Okay. Okay, next we have an application. We've got a wheelchair ramp that's 6 feet in length, and it has a 4-degree angle with the ground. So let's do a little labeling. It has a 4-degree angle with the ground, so that means that this right here is going to be 4 degrees. And the ramp is 6 feet, which is labeled. R is going to be the rise of the ramp. What we want to know is how many inches does the ramp rise off of the ground. So we are looking for this value here. Okay. So we know we can use trig for this, and let's just go through and figure out which one we can use. We're trying to find R, the rise, and from our 4-degree angle, that's going to be my opposite. So we have an opposite, and 6 feet is going to be, since this is a right angle, 6 feet is going to be my hypotenuse. So I have my hypotenuse. So that tells me I'm going to use the sine. So I can say the sine of my 4-degree angle is going to be the opposite, which is the R that we're looking for, over the hypotenuse, which is 6. And it does not tell us whether we want. Okay, so when I work through this, you might notice that that's really small. That's going to be a 4-degree angle. So if we work through this, we're going to find out that R is going to be equal to 6 times the sine of 4. Okay, and if we use the calculator to evaluate, you get approximately 8.42, and that's going to be feet. Okay, now that's really small. So what we might want to do is look at that as inches, in inches instead. So let's take this over here and say, all right, let's rewrite this as a sine of 4 is equal to R over, and change that 6 feet to inches, which is going to be 72 inches. Now if that's the case, then R is going to be equal to 72 times the sine of 4. And then we use our calculator for that, and we're going to find that R is approximately 5.02 inches. And that's probably going to be a better answer. Okay? If you multiply your 0.42 times 12, which is the number of inches in a foot, then you should get approximately 5.02. All right. Next, we have another application problem. And in this one, we have a diagonal path through a rectangular park is 600 feet long. One side of the park measures 350 feet. We want to know how long the other side of the park is, and at what angle does the diagonal make with the side whose length you found in part A. Okay, so let's start out by just sketching what we have going on here. So here's the diagonal, and that's going to be 600. Okay, this is our 350, and this is x. All right, so what we're going to do is find the value of x first. That's the length of the other side. How long is the other side? Okay, and that's going to be our x value. So to find that, we're just going to simply use the Pythagorean theorem. So x squared plus 350 squared is equal to 600 squared. So x squared is going to be 600 squared minus 350 squared. And then you take out the square root of both sides. So we're going to end up with x is approximately 487.34, and that's going to be feet. Okay, so we've got x. All right, and now we want to know what angle does the diagonal make with the side whose length you found in part A. All right, so that means that means that we're going to find this guy here. All right, because we found that. That's the length that we found. So we'll write this down until we get really good at it. We've got an angle that we're looking for, and from that angle we're looking for x, which is going to be our adjacent side. So let's count that one in first. We're looking for our adjacent, and we have our opposite, and we also have our hypotenuse, which means we have a choice between whether we want to use sine. It means we have a choice between what we want to use here. So it doesn't really matter. And actually, since we could also use tangent because we found the value of x. I would probably try to steer clear of using x, the value, the 4.87.34, or the 487.34, and that's because we rounded that. So let's stick with using the 350 and the 600. So if we stick with using the 350 and the 600, then that's our opposite and our hypotenuse. So I sort of messed up here at the beginning because we weren't finding x. We've already found x, okay? So we want to find the angle measure, and we would like to use these two is the deal. And from that angle, that is the opposite, and then that is the hypotenuse. So let's go with the sine. You could use any of them because we have found x, the value of x, but we would prefer not to use the one that we found because we did round. So we're going to say the sine of the angle we're missing, so sine theta, is equal to 350, which is our opposite, over our hypotenuse, which is 600. We're going to cancel out those zeros there, and I need to find, and this is where I'm going to use my inverse. Okay, and we use our calculators to find that, so let's put that in really quick. And we get approximately 3.69, 35.69 degrees. Okay. All right, so we get, and this is approximately. And then we have that application, and we have another application. This time we've got the angle of elevation from a point on the street to the top of the building is 53 degrees, and that's labeled. The building is 60 feet high. How far is the point on the street to the foot of the building? All right, so basically that tells us what we're looking for is we want to go to the foot of the building, is this x value here. So pretty quick here, we are looking for x, which in relationship, the relationship that x has with the 53 degrees is it's the adjacent. So we've got adjacent, and we also have the opposite. That means we're going to be using tangent. So I would say the tangent of my 53 degree angle is equal to my opposite, which is 60, over my adjacent, which is x. All right, now this time, because the x is in the denominator, let's put the tangent 53 over 1, and we're going to say x, use cross products here, okay, because we have two fractions that are equal, their cross products are equal. So we're going to say x times the tangent of 53 degrees is equal to 60. And I want to solve for x, so now I'm going to divide both sides by tangent 53 degrees. Okay, those cancel, and x is going to be approximately, and we can plug that in our calculator and find out that x is approximately 45.21. And that is going to be feet. Okay, a couple more application problems. Here we have angle of depression and elevation problem. So angle of depression is going to be if you think about looking forward in a straight line and your eyes make a curve down. So if you're a person, okay, and your eyes look across here, just parallel to the ground. Okay, now the path that your eyes, let's say you were looking at a bug, okay, and you look down to that bug, that's your angle of depression. All right? And now if the bug's head were over here, and there's a sight line that the bug has, there's going to be an angle of elevation. Or if you were looking up at the sun, which is blue, then this here, let's say that's a 20 degree angle, which is going to be greater than that probably, then that's going to be an angle of elevation. Okay? So there we have angle of elevation and angle of depression, just so that you understand those two. Okay, so we have this one labeled. So from the top of a lighthouse at a height of 100 feet above sea level, the angle of depression to the sailboat adrift, the water, is 55 degrees. All right, so we have an angle of depression of 55 degrees. And we want to know how far from the foot of the lighthouse is the sailboat. Okay, so we want to know what x is. Let's make sure we label that first. All right, so what we have here is we are going to have a 90 degree angle here, all right? So we know if our angle of depression is 55 degrees, then this angle measure here is going to be 35 degrees, okay? Because the 55 and the 35 are going to give us our 90. So we have that. We're looking to find x, and we have 100, okay? Okay, so let's think about what we have in relationship to that 35 degree angle. We're looking for the opposite. So we're looking for the opposite, and we have the adjacent. That tells us that we're going to use tangent. Okay, so I can say that the tangent of my 35 degree angle is going to be my opposite, which is x, over my adjacent, which is 100. And so x is going to be equal to 100 times the tangent of that 35 degree angle. And that means that x is going to be approximately 70.02 feet. Okay. And that's what we're looking for. Okay, now this next one we have a little bit more going on. This person is going to spot a small oak tree with an angle of elevation of 25 degrees, and it's labeled on the diagram that we have. and an angle of depression of 15 degrees to the bottom of that same tree. Her eye level is at about 165 centimeters. What we want to do is find out how far the person is from the oak tree, and then we also want to find the height of the tree. Okay, so the first thing is to find out how far the person is from the oak tree. So let's say that is our x value, and let's go and work on that part A first. And we've got our 165. Okay, so what we could do is we could work with our tangent, and what we also need to understand is that if that is x, then this length here in red is also going to be the same as that x, okay? So those are both going to be x values, all right? So if I can find the red x, then I have the green x, and that's what we're going to work with here, is to find that. Because I also know that if this length here is 165, then this length here is 165 centimeters. Okay, and now we've got our problem set up and ready to go. So we're going to start out with our SOHCAHTOA. All right, and we're looking to find x, which from the 15-degree angle, that is going to be my adjacent. All right, so I have an adjacent. And then we also have our offset, which is 165 degrees. So that's here, so that tells me we're going to be using tangent for this one. I can say that the tangent of that 15-degree angle is going to be equal to my offset over my adjacent, which is the x. And so x times the tangent of 15 is equal to, remember this is over 165. I used cross products like I did in the previous problem. I'm going to divide both sides by the tangent of 15. Those cancel, and I'm going to find out that x is approximately 615.79 centimeters. Okay? So now I have the value of x. The next thing I want to do is find out the height of that tree. Okay, so it looks like I'm going to have to use x in my efforts to find that. And I would like to try to avoid using the x value because I did round, but in this case it looks like the best option. Okay. So in part B, what we're going to do is we're going to look to find this length here, okay? Because what I want to do is find the height of the tree. Now, if I find this, I'm going to call it y. If I find y, then I can add it to the 165, and I have the height of my tree. Okay, so we're working from our 25-degree angle this time. And from my 25-degree angle, I do have my x value, and so I'm going to use that x value. That x value is going to be my adjacent. So the x value is going to be my adjacent. And I'm looking for my y value, which is my opposite. So it looks like I'm going to be using tangent here again. So I have the tangent of that 25-degree angle is going to be y over my x value, which is 615.79. Okay. Which I could leave its exact value in there to help me out if I wanted to, but we'll just do this for now. So I've got 615.79 times the tangent of 25 is equal to y. Okay, so let's plug that in the calculator really quickly. And I get 287.15. Okay, so now that I have that, I can take that 287.15 to find the answer. The 287.15 plus the 165 is going to give me the height of that tree. And that is about 452.15 centimeters. Okay. And that's all I have for section 6.2.